Yes, sir. Yes, you may, absolutely. All right. Good morning, ACT prep, or good evening, or good afternoon, whenever you're watching. We're going to take some notes really quick on exponents. Take my mask off so you can hear me. So at the top of your page, put exponent rules, or just exponents, whatever. Now, we're not going to go over this in the same sort of way that your ACT or that your math class did. We are going to hit the highlights and talk about some examples and some specific rules, but we need to also focus on how to use exponent rules to our advantage on the ACT. So we're going to talk some more about shortcuts. We're going to talk about strategies that you can use and things like that. So some basic things that you need to know is if you are adding terms, you don't change the exponents. I'm just going to abbreviate exponent as EXP. And then an example for that would be if you had a squared plus b to the third plus a squared. And let's just put another a down there as well. So if you have a long string of terms like this and you're adding or subtracting, you're basically just going to use the exponents to match up the things that can be added together. So I can add this a squared and this a squared, and I would get two a squareds because one of them here and one of them here is two of them total. And then typically I would put the single a up front that has no exponent, and then I would put b to the third in the back. You normally write your answer in alphabetical order and then in order of growing exponents. So an understood 1, a written down 2, and then our b. If I'd had b to the fourth, it would have gone after this. So that's adding or subtracting. You just use the exponents to match them up. You don't change the exponents at all. Then if you are multiplying terms, if you're multiplying terms, that is when you add the exponents. But only exponents of like bases. I'm going to go ahead and put or subtracting up there. So adding the exponents of like bases. Like bases would be a's up here or b's up there. So I'm just going to go ahead and use the same string of variables, terms. Well, if I am multiplying all of these together, then I have two a's that get multiplied, and then I have two more a's, so I'm up to a total of four a's all multiplied together, and then there's a fifth one all multiplied together. The way you would write 5 a's multiplied together is a to the fifth. So we added up 2 and 2 and this understood 1 that's right there. I'll write it in gray. And then your b's don't have anything to combine with, so it's just b to the third. It's helpful when you're multiplying terms to just do one letter at a time. So like know that when you're multiplying, you're going to go down and get all the a's simplified first, and then get all of the b's simplified second, and then all of the c's simplified third. So as kind of a tip, we're going to put over here one letter at a time. Then you want to check your answers. Because remember, our purpose here is talking about how to do exponent questions on the ACT. So if I'm looking for the correct answer, and I know it has to contain a to the fifth, I'm going to go knock off anything that does not have a to the fifth, because it can't be the right answer. If you do this, if you check them one by one, very often you'll be able to get the correct answer choice without having to solve the entire problem. So it's a strategy to save you some time. Also, you could do the same thing with negative exponents. So let me do another example. Just kind of put a box around it. And then we'll do another example over here. Let's say that we have a squared times b to the third times a to the negative second power. And I ran out of space, so I'm not going to do the other one. Well, you're still going to add up like bases, but you're just adding with negative numbers now. So I would add a to the second power and a to the negative second power. So there are no more a's. It's a to the 0 power, and anything to the 0 power is 1, which we'll talk about later. But there are 0 a's multiplied together. So they kind of cancel out, and it's just b to the third is what you're left with. So you're still adding, but you might have to add negative numbers. This is also true if you had decimals, if you had fractions, any of that stuff. So the the opposite function of multiplying is dividing. So when you are dividing terms, this is where people kind of start to be like, not real sure if I'm doing this right. When you're dividing terms, your goal is to get all of the like terms on one side of the fraction, top or bottom. So let's put that out here. Goal, get all like bases into one spot or as one term. That's one goal. Another goal is not to have any negative exponents in the bottom of the fraction. So another goal for simplifying, no negative exponents in denominator. If you'd rather put in the bottom of the fraction, that's fine too. So that's what you do, or what you're trying to do. How you do it is you're going to subtract the exponents Now, there's two different schools of thought on how you do that. Some people, I typically describe it as subtract bigger minus smaller and then leave the term where the bigger exponent was. Seems like a lot of words, but it's a pretty simple concept. You might also have it described as always doing top minus bottom. And then if you end up with a negative exponent in the bottom, you just move it. So subtract the exponents. And then we're going to do 2 or 3 examples of this because this is where people tend to kind of get a little bit more confused because it's not quite as simple as the others. So let's do an example up here. Let's say x to the 7th, y squared, z over x squared, y to the 7th, z cubed. Okay, now I usually do bigger number minus smaller number, and then I will leave that term where the bigger number was. That's how I do it. So the 7 is in the top, means I'm going to leave my x's in the top. Probably should have done that over here. That's okay. I'm going to subtract 7 minus 2, and that's going to give me 5. My y's are bigger in the bottom, so I'm going to leave y's in the bottom. And then 7 minus 2 is 5. Makes sense. It's the same set of numbers. Z's are bigger in the bottom. What's the exponent on this top one? It's 1. So we're going to do 3 minus 1, which is 2. Now, the benefit to doing it that way is if you always do bigger minus smaller and you leave that where they were bigger, like we did here. I left the y's in the bottom because it was bigger in the bottom. If that's the way you do it, it'll get rid of your negative exponents automatically. The other way that you can do it, we're just going to kind of link these two. We're going to do the same example 2 different ways. X to the 7th, y squared, z over x squared, y to the 7th, 7th, z cubed. I'm going to go side to side on this one. Now, the other method is you always subtract top minus bottom. 7 minus 2 is going to be 5. 2 minus 7 is negative 5. 1 minus 3 is negative 2. All of my terms had a partner in the top and the bottom, so I don't have anything left on the bottom. But you really, if you want positive exponents, so we're going to put over 1, you can then move these to the bottom to make them positive. So the x is already positive, it means it's happy where it is. The y is kind of negative, it's not happy where it is, so let's move it to the other side. The z is not happy, it's got a negative exponent, so let's move it to the bottom where it can be more positive. Now, whichever way makes the most sense to you, you just pick one and roll with it. The result is the same. X to the 5th y over y to the 5th z squared. X to the 5th over y to the 5th z squared. 100% the same. So you pick whichever process works for you. Personally, I feel like this one is more efficient. And on the ACT, it's all about being efficient. I did this in 1 step as opposed to 2 steps. But whatever floats your boat. So that is dividing exponents. I also want to do some, let's do just another one down here. Let's do f to the negative 2nd g cubed over g to the negative 1st h squared. Now we don't have a 1-to-1 match. F doesn't have a partner in the bottom, H doesn't have a partner in the top. We also have some negative exponents. So that's how this particular example is a little bit different. But the process is still going to be the same. I'm going to pick wherever they're larger, and I'm going to leave them there. Well, negative 2 is the only one that I've got. So I'm going to just leave that at the top for now. Or if you realize that, it's negative, it's not very happy up there, so we're going to move it down to make it positive in the other spot, you can do that as well. Let's do that so that it can all be positive and simplified in 1 step. Next is my g's. I've got a positive 3 and a negative 1. Positive 3 is bigger. Make sure when you subtract, you're doing 3 minus negative 1. Minus negative is like plus. So 3 plus 1 is 4. And then h, there's no other h up here. The exponent's positive. It's happy where it is. So h squared. Oh, I should have. Sorry, my boxes are getting a little bit, getting away from me. I forgot what I was boxing. So 2 totally different examples, top and bottom. The first one had 2 different methods of how to do it. Dividing terms. Next is raising a power to a power, or exponents of exponents. Exponents raised to a power. When you have a power to a power, so like 2 cubed squared, you multiply those exponents together. We'll do a couple of examples here. One with just plain old variables. So maybe you have, what's the letter I haven't used? I haven't used C. Let's do C to the 10th to the 9th. Well, you just multiply those 2 exponents. So 10 times 9 is 90. So C to the 90th. You can do this as well if you have fractions. So let's do D to the 7th over E squared raised to the 4th. Since D and E can't combine, they don't have the same base, I'm just going to distribute that 4 here and here, and I'm going to multiply both of those. So 7 times 4 is 28. D to the 28th is the new top. 4 times 2 is 8. E to the 8th is the new denominator. So there's one example. There's a second example. On our third example, I want us to have some terms that could possibly combine. So let's do D to the 7th over E squared, and let's put F to the 3rd over F squared right there. And then raise it all. We'll just do the 4th power again. All right, so you have options. Technically speaking, in order of operations, you need to work anything in the parentheses first. So F to the 3rd over F squared, that can be simplified. It would be a single F in the top. So technically, that's what you ought to do first. So F to the 3rd over F squared, that's just going to be F to the 1st. Because you're going to do 3 minus 2, and you're going to leave it where there were more F's. There were more in the top. So that's an understood 1. Then you can distribute, again, to all three now, exponents. So it's going to be D to the 7 times 4, which is 28. F to the 1 times 4, which is 4. And then on the bottom, E to the 2 times 4, which is 8. Okay. So we've kind of already talked about negative exponents, but there's just 2 little kind of rules that go along that I want to cover, go along with exponents that I want to cover. For negative exponents, all you're going to do for negative exponents is you're going to move them to the other side of the fraction, period. If they're negative in the top, they're not happy up there, move them to the bottom. If they're negative in the bottom, they're not happy down there, move them to the top. So we're going to say move to other side of fraction. And we've already done that. We did that up here with dividing the terms, right? We had y to the -5th, and then we brought it down to the bottom and made it positive. So I'm going to just draw this arrow right up there, because that's where we did that. And then the only other little thing is the 0 power. So I'm going to put kind of a star. Anything to the 0 power equals 1. Anything. And we actually saw that as well. Where did we see that? I think it was, it was on that very first example of multiplying. No, the second example of multiplying. So I'm going to draw this arrow from the bottom. I'm going to go up here to right there. We said a to the 2 plus -2. Well, that's a to the 0 power. 0 power is 1. You don't have to write the understood 1 because you had another term there. So anything to the 0 power is 1. And that's pretty much exponent rules. Now, personally, I think it's quicker to do exponent problems if you know the rules rather than using a strategy. However, it's always good to have a strategy if you happen to be on the test and you're just drawing a blank and you don't remember what the rules are. So back up at the top where you put your title, questions with exponent rules can very often be used with make up numbers strategy. Make up numbers strategy. Often, not always. Okay, so what you would be looking for is a matching value after you have plugged in a number. So for example, let's say that I took a squared, b to the 3rd, a squared, a, and I'm adding them all together. Let's say that I said a was 4 and b was 2. Okay, so I would do 4 squared, 16, plus 2 cubed, which is 8, plus 4 squared, which is 16, plus 4. So there's 16 and 16 is 32, plus 4 more is 36, plus 8 is 44. Okay, and then I would plug them all in the answer choices and see what came out to 44. So that's how you use the makeup number strategy. And again, it's often, not always, but often. It will take you longer to do the strategy, but you will get the right answer. So these rules, in my opinion, are worth knowing because it'll save you time and they're not super hard. Trying to think if there's anything else. I'm pretty sure that's it. Remember to check it one letter at a time. That's not just for multiplying, that's for all of exponent rules. Check it one letter at a time and you should be good. All right, so that's our notes. You do have an assignment. It is in ACT Online Prep. It's called Exponent Practice. There's 2 components to it. One of them is like a little lesson where it kind of reviews all of these rules. And then at the bottom of the screen, you have about 4 or 5 questions to answer. Let me share that with you real quick. Okay, so here it is. Exponents practice. Oh, I bet I've got to go in. Yours is going to be in a different spot. You've got exponents lesson. This is all the same stuff that we've gone over. So you can kind of scroll down to the bottom and you can go ahead and try to answer these and it'll tell you if you're right or wrong. Then there's 17 questions on exponents and they are ACT style questions. Now, whether you choose to answer those by using the rules that we talked about or whether you choose to use them with the strategy, it's totally up to you. Just do your best. Any questions? All right, and folks at home, if you have any questions, feel free to email.